Greetings, everyone. This is Eric Andelin, Senior Photogrammetry Workflow Advisor with SimActive, and you're joining us for the workshop, Creating 3D Models from Point Clouds with new Correlator3D version 10.4. And with me, I have my guest, David Alamillo, Photogrammetry Specialist at SimActive. David, say hi to everyone.
Hey guys, how you doing? And again, thank you for the invite, Eric.
Wonderful, wonderful. And for those that don't know you, give them just a quick little background of what you do here at SimActive.
Sure. My name is David Alamillo. I'm the Photogrammetry Specialist here at SimActive. I have to work with support success here at our company, and I also help our sales team with our demo portion of Correlator3D. So I probably met a couple of you guys really quick during our sales demo, but again, happy to be here and always happy to help and lend a hand to make this process as easy as possible.
Perfect, perfect. So I will give everybody the topics of our conversation today. Here they are: understanding the optimal sensors for 3D modeling, generating the best point cloud possible from imagery, performing triangulation to generate a texturized mesh, and using lidar point clouds for modeling rather than photogrammetry. David, before I jump into that, I just want to let everybody know that version 10.4 has a little bit more to it than just what we're doing with 3D models and point clouds. So we will also kind of briefly go over those as well during the course of the conversation, and we'll hit those at the end as well before we go into the demo. That being said, let's start with understanding optimal sensors for 3D modeling. And basically, what it comes down to is the types of sensors you are using. We have nadir sensors and we have oblique sensors. We have nadir sensors that are on a gimbal. We have nadir sensors that are fixed mounted, and we have the same for oblique images. So you can use a nadir, you can use a camera on a gimbal to get an oblique image in any direction. But you can also have a specific sensor built or purchase one that has not only a nadir camera straight down, but it also has one pointing left, right, forward, and backwards. So there are all kinds of options there. And then, of course, we have lidar as well. So David, kind of give people a little, of your thoughts on how you would use these sensors, which are the optimum ones to use for this type of work when we're creating specifically going for 3D meshes.
Absolutely. And again, the description of all the sensors is a true testament of how the industry has been advancing over the last couple of years. Starting off, I remember, and maybe you remember, these GoPro sensors mounted on drones, no type of gimbal, straight down picture. You get what you get and you make it work. Again, it was early on in the industry. We did the best we could with those type of sensors. And then DJIs came along with the nice gimbal, and we're like, whoa, this is a whole different world. And again, I remember trying to process more than just photogrammetry or mosaics, 3D models out of those sensors mounted, nadir only, and small sensors. And the outputs were terrible. They were the worst I've ever seen in my life. They didn't even look like a model. So, meshes were so hard to get. And then we moved on to the second option, which was, gimbal. And you started getting, like you said, a little bit more options on how that gimbal performed and the tricks and tips you could get when trying to fly certain missions and try to fly oblique, try to fly nadir, and then combine those missions. So there were many options there that we could explore. And then I remember bumping up into the next setup, which was DSLR cameras mounted on fixed-wing drones, for example, where they had a slight oblique angle when they were capturing the images. And that introduced a little bit more detail to the facades, to the side of buildings and whatnot. City mapping became now a little bit more possible, where you would get sides of buildings. And I remember saying, what about if we include a camera that was natively an oblique camera? And then came those Sony, for example, I'll give a number here. It was the A6100 oblique sensor, which is natively oblique. And you get a portion of nadir within the same sensor. And that introduced another realm of detail and finesse into the process. So as the sensors start getting better, my models started getting better. So I discovered that, oh, okay, great. Now I have the option of getting obliques plus nadir. Let's see how those look. And finally, we get into the last couple of years when we start introducing the nadir plus multi-oblique. And this setup has been great for the most part. I'll say when it comes to the medium large format sensors, it's amazing.
Yeah.
When it comes to nadir, well, nadir plus multi-oblique or those only multi-oblique sensors for UAVs, I struggle with those, Eric. And one of the main reasons is not accurate EOs. Also, some of these systems don't capture any type of roll, pitch, and yaw. So when you're trying to import all these images, you basically have no type of attitudes for the imagery collected. And that poses, again, one of the challenges in how you process these type of sensors. However, as I said before, we've been trying to keep up with the industry here at SimActive, and you wrote a great document. It's in our reference documents in our webpage that talks about this specific setup and actually this specific type of sensors and how to address that. So we have a complete workflow of addressing this type of imagery with no type of attitudes, no type of roll, pitch, and yaw, and in actually producing a 3D model and an output. So again, very happy to be working on these systems. You learn a lot every day working with these systems. And again, medium large format, I believe they're in a different level because I've seen multi-oblique, where you have your front, back, left, right nadir in a single body, and with accurate EOs, smooth as butter. So
Yeah.
in general, that's kind of a quick overview.
Yeah, and I would say the challenge with any multi-sensor system is that is the quality of those individual sensors. So if you've got a calibrated aerial mapping camera in a medium format or a large format situation, it's great. And if you've got two opposing cameras like in a phase one to create a larger footprint, they're both two good cameras attached to a good IMU, so you're going to get good EOs and you're going to have good luck, good probabilities of good processing with them. When you start talking about an off-the-shelf, multi-oblique camera for a drone, that becomes a challenge because they're not necessarily the best cameras, and certainly the positioning systems on them are not that good. So you really have to let the software do the work. And you have to trust in the software to do the work. And, a lot of people, they get fixated on, well, you moved my camera. Yeah, because the reported position of your camera is incorrect. So
Yes.
there are things like that you have to kind of let go. And one unique way around that is in your flight planning. So if you've got a single camera, whether it's on a fixed wing or on a gimbal system, and you've just got it forward 15 degrees, then if you fly that path, that lawnmower pattern in both directions, you've now captured forward and backwards. And if you fly that pattern in a crosshatch direction twice, you're going to now have right and left. So you got all that with one sensor, and that one sensor has the same camera parameters. And so that's one way to get around that. And then now you've got what DJI is doing, which is, I think you called it their smart oblique camera. Was that it?
Yes.
Yeah. Explain that a little bit.
As you mentioned before, taking advantage of the way the drone is capturing the data, using the gimbal, using the flight patterns that come default into the drone. You have these new methods. This one has been out for a couple of years, but they've been refining it as well, to the point now that with Smart Oblique, you basically set your AOI and the drone basically does the magic, right? It will capture it in different angles, different altitudes, and try to give you as much material as it can to produce a nice 3D model. One of the things we've done, like I said, is we see the industry advance is also make those advancements ourselves. And when you import these type of missions into Correlator3D, the software will automatically parse, basically each camera, and it will prompt you and tell you, this is a smart oblique data set. Would you like us to parse out these cameras for you automatically? So this is a huge advantage that you don't have to be separating these cameras separately on individual folders. The software will do it on its own.
Yeah, and that's one of the new features in version 10.4 that I was mentioning, because it has applications outside of modeling as well. So we'll keep that in mind. And then the last thing that we could mention in here is that you can use lidar for 3D modeling or for building meshes, and especially now that we're capturing lidar and imagery at the same time, that helps out quite a bit. In the old days,
absolutely,
way back in the beginning, when people were using handheld, scanners, they were using Leica scanners, and they were on the ground and they were modeling buildings and all that. That's the way to do it, because you're getting that view. The only thing you're missing is the top-down view, which comes from imagery. And now we're seeing that become more of a popular thing. Again, with drones, you're capturing small areas for that model. With large format systems, you're doing city mapping. And that city mapping, again, is a higher altitude. The GSD might be different, and you got to look at the granularity of what you're trying to build. Because if you try to build a mesh of a city, you're going to run into all kinds of processing problems. But it can be done. And if you're doing it with a drone, it's not a problem at all, because you're capturing a smaller area. So let's talk about generating the best possible point clouds from imagery. From your experience working with our customers and our data all the time, give us kind of some semblance of best practices for these folks.
Sure, absolutely. And as I mentioned before, it always starts with good capture, right? I always, during the demo, try to ask folks questions about best practices when they're out in the field capturing data, and working with several companies, companies who are very well established, been here for years. They have a great SOP on how they capture their data, standards and regulations. And, you know that the data you're going to get meets certain standards. And then you have companies who are starting and they're like, we don't have any methodologies, but we go out there and do the best we can. So I always remind folks, it's always good to have a document, internal document, some set of, expectations on what you want from the data set you're capturing, what you're aiming for, and on top of that, what you expect from your pilots, right? What type of data do you want them to capture? And it's important to communicate that. So I think that's number one in my list. Number two is always bringing back the imagery. I always tell the guys, rule of thumb out in the field is capture more. You don't want to go back and capture what you missed. Rule of thumb back in the office for a photogrammetry guy is like, wow, they captured too much. Let's lean this up a little bit.
Yep.
And in that process of eliminating what they captured is cleaning up, certain takeoff images, landing images. And sometimes you even see overexposed images out there where you're like, this image doesn't look right. Eliminate it from the collection. And you can't imagine how these 10 minutes that you spend on the data before you even input into Correlator makes a difference. So, of course, you can do it within Correlator as well once they've been uploaded and the project has been created. But I always typically recommend doing it before and just scrolling through the data really quick and the images to see what you're importing. So that would be number two. Now, once you're in Correlator, we have some amazing tools of filtering those images. There's a new functionality that I'm pretty excited about, which is adding a polygon.
Number two.
Number two. To remove it. Before, we used to have a rectangular tool, which, depending on how your flight lines were oriented, it was so difficult to pick. You would pick more than what you needed. Now you can draw a very nice polygon and just eliminate or select those images, for elimination.
Yeah,
that's a great tool. And guys, use it. This makes a big difference, in the outputs you're producing. Now, getting into the data processing, I will probably have to separate these, Eric, by sensor.
Yeah.
UAV sensors, typically we recommend when you're generating your DSM and point cloud optimal setting, which probably familiar with it. You get your optimal, maximal, and coarse. For all UAV folks, I always say start at optimal. You can always push it further or do a rerun if you want, basically push it a little bit further to 2 or 3 times your GSD. depending on the sensor and the quality. But you always want to start at optimal. That's a good place to start. Not a lot of noise. You'll get a good feeling of what the sensor is going to produce, and then how dense your point cloud is. Max observations, usually I tend to go max observations on the point cloud. Then I'm able to filter them, of course.
Yep.
But that's an option. When it comes to medium large format, it's a little distinct message. You paid a lot for that sensor. Push that sucker to the limit. So we like to go with 2 to 3 times the GSD on those type of sensors. Anything medium large format sensors, and try to multiply that maximal GSD times 2, 3. Drone folks, again, optimal means 5 times. So we multiply that max GSD you have for that sensor times 5, and that's how we get to optimal. So that's kind of a little, again, tip and trick that I always cover on the demos, but that's, I guess, very good practice to generate your point clouds. I don't know if anything to add on that, Eric?
No, I mean, I agree that when you go towards maximal with a lesser quality system, you're just going to create more fuzz, more issues.
Yes.
With a higher quality system, it's built for that, so it can handle it a little bit better than that. And then back to the one thing you said in the collection, yeah, we tell people all the time, collect as much as you can out there. And also in Correlator3D, you can bring it all in. That's not a problem. And then you can just turn it on or off within Correlator3D. So like you said, sometimes you get images that are just blown out. And it's not because of the way it was captured. It's just the fact, the sun angle happened to hit it. And maybe you got a whole flight line that's just blown out image. And what's going to happen is that's going to mess up your mosaic. You may still want to use it in the AT, but you can always turn it off later on down the road. So just like they say in the world of LiDAR, keep every point. I say the same thing in imagery. Keep all the imagery. You can always add it or remove it later. So that's kind of what I think. And then there are somewhat LiDAR editing tools within, or point cloud editing tools within Correlator3D as well. You mentioned, how many looks we keep when we create that point cloud.
Yes, 6 observations is usually what I go for. Again, it's one of those where you say I like to produce more and then filter out any outlier points. And we'll be covering that pretty good actually in the webinar. So there are a couple of ways you can filter those point clouds, which make a lot of sense, when you're moving on to produce your 3D model.
Yeah. So, it's not like we have robust LiDAR editing tools. That stuff gets done somewhere else because we don't create LiDAR, we create point clouds from imagery. The next thing we're going to chat about is the performing aerial triangulation to generate a texturized mesh. There is a difference than doing it for a volume comp and doing it for a texturized mesh. So kind of explain to people what that might be.
Absolutely. AT plays a impressive role in this entire process, right? Like with any solution. Actually, this is a very good point you touch base on. I know the automated workflows, and more nowadays with AI, they tend to be very tempted because you just press a button and get results. But I always remind folks, the AT is something you always want to do as a manual step. You always still want to have human eyes on it to see how good your AT is before you move on to the next steps, especially for a large data set. No matter how good your sensor is, no matter how good your EOs are, I always like to keep an eye on the AT and see how good of a job, the process is doing in general. So I guess a very good important thing is to look at your AT. Don't be shy to do a second bundle adjustment. Often you'll do a first bundle adjustment, get excellent results, and you'll be like, I'm done with it. Cool, let's close this thing and let's move on to the next thing. But keep an eye on those residuals, on those images, right? I don't say that everything needs to be completely green, but sometimes there is a combination of yellow and green images. Don't be shy. Run another bundle adjustment, another iteration. You might even get a better and stronger AT that will, I guarantee you guys will produce better results, for any of the processes going for further. It could be your 3D models or your point clouds. But yeah, that's something that I'll definitely highlight. And there's a function to actually filter those high residual images within that last bundle adjustment. You can do it at the last bundle adjustment step or as a ultimate step and just filter images, set a threshold, and eliminate those high residual images. But yeah, there's no problem. A lot of folks are shy to run bundle adjustments, Eric. I've noticed that they run one, they're like, it looks good, I don't want to mess it. So no, don't be shy. You can always delete it. That's something cool about our software. You can always delete. If it looks worse, delete that and stay with what you had.
Let's talk about using lidar point clouds rather than photogrammetry. So give people a little bit of idea what we could do there.
Yeah, it's I always talk about lidar because it's more and more popular, and I see more and more folks. Like you said early on, they're collecting more lidar data now, and they say, "How can I use this?" And when they have all those LAS files, LAZ files, I simply tell them there's an option here to file import lidar LAS, and they're like, "Whoa, you can drop in like 20 LAS files." I was like, "Yes." And it will produce a surface. Yes, sir. And it's much faster than generating from photos. Yes, sir. So that option saves a lot of time. Yeah. I would have to say that, while we produce excellent point clouds and surfaces, I love how we address that part. Bringing it in just cuts a lot of time, it cuts a lot of time from the processing, because we do dedicate a lot of time working on that algorithm to produce a very nice surface. So take that out of the equation, and now you bring in that LAS and you have a very nice surface, which on top of that, you can extract GCPs from if you bring it in, extract the intensity. Yep. So it just adds, I guess another layer of convenience for folks that don't want to generate, don't want to waste more time, just bring in that lidar. And now they can use it for 3D model generation as well as an input. So that is a huge factor in there.
So the one thing I would say to that, and I mentioned this earlier, is that the rule of thumb when you're working with lidar is to keep every point. In fact, specs require that. If you're delivering to USGS or something like that, you have to provide all the points, whether they're used or not, whether they're non-class, whatever class they are, they got to stay. That presents a problem for us in our world, because we're bringing in your point cloud, and if you left that bird strike in there, that becomes a spike. So you have to be aware of that as someone who is working with point clouds and bringing them into Correlator3D. For example, if you want a bare earth surface from a point cloud, then take all those points and bring them in. That way the software has to do nothing. Otherwise, there will be some editing, and the tools you have in the lidar world for editing lidar point clouds are more robust than what we have in our world. We can still do it to a certain degree, but there can be challenges, so just be aware of that. And then the last thing about bringing in lidar point clouds is to make sure that you ensure it's in the same projection or coordinate system as the other information you're bringing in. So
yeah, that's an excellent point.
Yeah. On that note, I think we could go ahead and get into the demo and start showing folks some of these features, because listening to us talk is fun, but it's not that fun.
Absolutely. Let's show the guys what we have, and let's give them a quick view of these projects. As I mentioned earlier, we have data sets that we've been processing for a long time now, and seeing what gives great results, what still needs work. So today, the two data sets I want to cover with you, Eric, are one taking with Wintra. It's an RX1 R2 project, mainly nadir images, but we do have lidar for this project. So I'm going to show you guys a comparison of 3D model generated from LAS import, basically the lidar file, and then one generated from a point cloud that was generated from images. So those are basically the two examples. So let me go ahead and share my screen here.
Yep.
And get started. So we'll start off with this particular project. So I mentioned before, Wintra RX1 R2 dataset. What we're seeing right now in your screen on the left-hand side, we have the two 3D models. One 3D model generated from the point cloud, generated from our images. So the point cloud is actually right here. And then you see a point cloud underneath, which was imported directly from the outputs from that WingTray unit. So we have the two 3D models here. The first 3D model I want to show you guys is a 3D model generated from from images. I'm sorry, it's called 3D model images demo. And we'll spin it around and then we'll talk about it, how I generated this in Correlator. Let's go ahead and click our view option, go to 3D views, and we'll hit the full screen button. So let's zoom in here into a particular area. And I want to remind the folks, I could probably show the imagery, the raw imagery that was used to produce this 3D model. But this is from a point cloud generated from the images. So quite a nice output there. I'll stop moving it there for 1 minute so you guys can get a better view. A lot of vegetation, Eric. This is something that a lot of folks talk about. Generating 3D models sometimes creates a lot of issues with vegetation. So this was a very nice data set to accomplish that. On top of that, solar panels can always be tricky. They're very reflective, so they always can be tricky when you get complex surfaces and then add vegetation to it. So again, this is a very nice example of what you guys can do with that particular sensor in Correlator3D.
Yes.
And I don't know if you have any comments before I start talking about on the steps on how to produce this.
No, I'm pretty good with that. I'm still very impressed in the change in what 3D models look like these days.
You should see what I used to produce with that GoPro.
Yeah.
It would definitely be very embarrassing, but yeah, I'll blame the sensor, not the pilot, because back in the days I was the one doing the flight. So. Yeah. I'll have to blame the sensor on this one. Nonetheless, what do you need to generate a point cloud like this? So the first thing, we'll go into our DSM module. Again, we're already finished our AT. We know our AT is perfect. We did the best we could with our AT, so we're moving on to the next module. First thing we're going to cover is the resolution. This particular sensor, of course, pretty good sensor. I mentioned early on with these type of sensors, I typically like to go with optimal. If I see it can push the sensor a little bit more, I tend to go for 3 times the max GSD. In this case, we take 0.028 multiplied by 3, and we get the magic number of 0.084 meter resolution. This is what I did for this particular data set. Again, depending on the sensor. I started with optimal. I said I can push this a little further, went with 3 times my max GSD. Again, folks, don't be shy, try optimal, review your results, and that's something that you guys can do fairly easily by inputting the number manually into your resolution section here. The next part is generating your point cloud. So you have to turn on option generate point cloud. And you can see we do have a very new option here in Correlator. It also generates a DSM that it's optimized for true ortho. This is the whole conversation on its own, Eric. So yes, it is. I know there are folks going to get a kick out of this. Yep. And we'll probably cover this again, maybe in another webinar. But yeah, true orthos are always difficult, and you get some noise. This time, your true ortho, your DSM, is going to be generated at the same time as your point cloud. So it's going to be a pretty nice and precise DSM, very, very well tailored for your true ortho, requirements. Yep. One thing I told you to do: go observation 6. That's something that I always want to have, and then later on I can clean it up. And the last process is if I want to colorize or not, optional. So I can just hit the process button, and that will output my first piece of information, which I need is my point cloud. Now, again, we talked about the second option while our point cloud is loading, and the second option is we bring a point cloud that's already been processed. In this case, we have already the LIS file, so we can import it. Just so you can spin around this a little bit, let me go back to 3D view to show you the point cloud. We'll turn off our 3D model, and we'll zoom out here for 1 minute so you guys can take a look at the point cloud. The next part of this is moving on to generating my 3D model. So now that I have my AT done, I have my point cloud generated, I'm going to go and access the 3D model generation module. Give it a go. And you see on the input, now we can use a loaded point cloud, loaded 3D model, and we can also do DSM if we had a DSM. Of course, that defaults you back to 2.5D. So this is your best option. Go for a loaded point cloud. And here you have options to generate the texture, yes or no. We can talk about a couple of hacks here as well as how we do this later on. But you can set the generation of texture to off and simply generate, the mesh at a specific model size, and then texturize as a second step. That's also a very good practice. In this case, we'll leave it on. Set your model size. I mentioned this earlier. It gives you a little description here in the notes of what the software is going to produce. The texture will contain 4 files. And depending on how you change this, those notes will change, and of course the parameters will change. So I suggest folks starting with something very in the middle. Go for 1024 megabytes. I think that's a very good place to start. You can always set the optimal at 256 if you just want a quick 3D model, see how it looks. Again, if you want to push a little further, go for 1024. Should I do maximal? Always a temptation. Should I always? And it's keep in mind, guys, the software will handle it. The hardware specs are something that might not. So depending on what your hardware specs are, I always say keep in mind the software will run, but it might kill your machine. So no, all jokes aside, it might not kill it, but it will take a while. So I always say be mindful of your process, of your hardware as well when you're running any of these processes, either point cloud generation or 3D modeling. They're very intensive, so keep in mind that. Again, once you process it, you'll finally get your 3D model there processed and ready to go. So this is option number 1. I don't know if you have any questions here, Eric.
Nope, I'm good.
Awesome. Well, option number 2, we have the LAS. We simply go ahead and import it by adding a point cloud to the project. We will browse for that LAS file. Once you bring it in, you can always take a look at it. And here's where I'm probably going to spend some time showing folks how to address sometimes those outlier points and how to filter, those points. So again, it's not colorized, so we can see this. It's just black dots, but we can always switch it to elevation. So that's something you can do here on the top right-hand corner, switch it to elevation, and now this gives it a little bit more context. I want to show you folks how to filter your point cloud, especially if you're bringing this, from your system, it's raw. Point to Eric. You have way more tools in your lidar stack tools to clean up this before you bring it in. However, we have incorporated a couple that will help you. But I do suggest doing it, before you bring it in. And one of the first one is you can obviously here not do it by observation, but you can do it by elevation range. So if we go by elevation range, let's turn this on for a minute. Let's tilt a little bit this view. We can set the elevation range to whatever we want the software to clip. And again, this is actually live, so you guys will be able to see changes live as I'm filtering the elevation ranges here. And that's amazing, because if you need to filter outlier points that are a certain elevation, you will see it before you save it. So you're like, oh, I want to filter, at a certain range. You can always move the sliders and see it in real time what points you're actually filtering before they get filtered. So again, it's a very handy dandy tool when it comes to the elevation ranges. And the question sometimes folks ask me is, can I use this on the point clouds generated in Correlator3D? The answer is yes, absolutely. You can do it on the ones you import. You can do it on the ones that generate in Correlator. And the second one is area. If you have a polygon, bring it in. You can browse for that polygon as a shapefile, DGN file, and then simply crop it by area. So you can keep or exclude whatever the option you need. And if you allow me, Eric, I'll just show the folks by observation. Let me switch over to the previous point cloud. And we'll check that option because it's not available for the one, that you imported, but it is available for the one that you generated in Correlator3D. So let me load here the point cloud really quick, and you guys should be able to see that option enabled. Let's go ahead and go to process and point cloud filtering. And here we go. We'll put this to the side here at the bottom. Number of observations, and you can remove points with 2, 3 observations, 4. And then, of course, we might need a little bit more than that. So you can always filter by this option as well. And you can combine them. So that's something cool, right? You can combine that alongside, the other filters that you have built into the software. So it's a very neat tool, again, but you always have additional tools in those particular softwares when you produce these point clouds. So that's again, another option. And maybe to close out this part of the demo, at least this particular project, Eric, I want to show you guys the one that we did when we import the lidar. So this is from the lidar that we imported. We ran our AT. Important point here, I did extract some GCPs from the point cloud and, of course, from the DSM. But you can see the results are actually pretty nice, pretty good. Some might argue that it's better than our images. I don't know. I'll say, I don't know, maybe not, maybe yes. But, for a sensor, it's not capturing any obliques. You have some, of course, issues here on maybe the facades of the buildings, expected as, again, they're nadir images only. But a very, very nice model, giving all the vegetation and the different, type of roofs that we have and complex geometries there. Yeah. So that's example number one. We can move on to a data set that was captured with the purpose of building a 3D model. Would that be cool with you, Eric?
Yeah, absolutely.
Awesome. Let's go take a look at this one. And I believe we'll just have to minimize the screen. And there we go. Well, now we see a very complex flight. You mentioned this. This was great because crosshatch pattern, you got images, and I'm seeing the preview of the image here so you guys can see it. This is, again, what we call, you can see it here in the preview, I think would be better, a low oblique. And I don't know if you've heard that term very often, Eric, but a lot of folks, when they're capturing data sometimes for this type of purposes, they try to hit the sun, it's taking pictures of the horizon. Sometimes it's like, well, that picture's not doing any good. It's not even focused on the building. It's focused on the mountains and the sun. What I like to talk about, folks, is doing low oblique, which is just the camera's tilted, to the front. And it optimizes that angle to really produce like rich details and vertical facades. And it doesn't have to point the camera all the way to the sun. And this is something that a lot of systems are doing. Folks out there, I truly recommend setting your flight parameters to low oblique. It's going to give you some excellent results. And of course, we have here to complement the crosshatch pattern, which is amazing. And just to give you guys some options, I believe this is from the Sony A6100 oblique. So it's natively oblique. And it's an excellent sensor, I believe, in my opinion, one of the best sensors out there in the market right now for city mapping and 3D modeling. But let's go ahead and give this guy a spin. Let's change our view really quick here through 3D and go full screen. And this looks a little bit different from what we were seeing earlier, right? Let's spin it here around and, oh, what you know, got details on the facades. We can see the windows. We can see a little bit more than what you typically would see with only nadir sensors. And again, this is just a low oblique sensor. So we're not even talking multi-oblique, front, left, back. This is just using that crosshatch pattern. And I'll try to spin this around as best as I can. And you guys will be able to see the details on this particular building right here. Again, I don't know if you have any comments about this, Eric.
No, I was just going to say, about 20, 30 seconds ago, you had the angle where it was showing a blue minivan. And the blue minivan was parked under the trees, and you could see the van undistorted under those trees. Pretty nice stuff.
Yeah, absolutely. And this is the magic of that low oblique,
Yep.
minimal effort actually. I don't know if I'll be able to find the van,
You're
but
fine.
I mean, the data set is quite nice.
Yeah.
Again, we might be able to shoot you guys some screenshots of it, but
But yeah.
yeah, a lot of details there on the facade.
Yeah. Very good. Very good stuff.
And this was produced in the same manner. We simply created the point cloud from the images. This wasn't by importing our lidar. It was basically by creating the point cloud at the same time as our DSM, and then just simply creating our 3D model. Um, with that said, I talked about another workflow where you could potentially just create, your mesh. Sometimes that is an option. Let me load the mesh really quick right here. So if you have a mesh, you can bring it in and then texturize this. So that also Correlator does give you that input. If we go to 3D model generation, you'll see you have that option here in the drop-down menu. You can use the loaded 3D model and then texturize and of course adjust your settings. So that is a nice workflow. Typically what I do is I'll generate a mesh that is, low, we'd say on the model size, and then come and texturize at a higher model size. So if I generate, for example, no texture, I can generate at, 30, 40 megabytes. And then when I come to texturize, I can really, really push the boundaries of that to use a higher model size, maybe down into 2 megabytes, 1.5. So again, these are basically the options we have from that, and the new 3D models and options you have to generate from the point cloud.
Yeah. So in that instance, you're getting the best of both worlds because you're putting together a low res mesh and then coming back and using that and creating high res textures on that, which kind of allows you to get more bang for your buck in all senses, because what becomes the challenge here is not the software's ability to do it, but your processing hardware's ability to handle it, or
Exactly.
how long you want to wait for it. So
Yes.
always, think about there's that blue band back in there. Always think about what, your output is, what your who your end user wants, what they want as an output, because we tend to want to make the highest resolution, best thing we can. And that's all good and well, but there's a price to pay for that. So you just have to be aware of that. And if it's not what your customer really wants, don't necessarily, go to those lengths. Maybe it's more about getting it delivered faster.
I completely agree. Then that was part of our first points, right? Talking about what the client needs, and sometimes even displaying
Mhm.
data is quite heavy. I'll maybe touch up base on one function that a lot of folks forget is you can share your results.
Yes.
Through your Cesium profile. Share those 3D models with your client via that method. And we do have a quick start guide on how to enable you to start that process and link your account. But that's a neat way of sharing these results that, even if it's just for your portfolio and want to show off there, it's a really nice way to share those 3D models.
It is, because you're just using a web browser link, and the person on the other end doesn't have to have any kind of powerful computer or anything like that. But they can go in and view and zoom around and check things out. So I still don't know, honestly, what the value of 3D meshes is in the real world. I know there's this, there's this whole digital twin idea, and that's wonderful.
Yeah.
But I don't know who's paying for it yet. So at this point, even if it's just a novelty, to be able to share it is where we start. And when people start to see it, and they start to see comprehensive and repeatable results from different users and organizations, then it standardizes, and then people start to want it, and it pushes the ball down the road a little bit further. So you have the capability now in Correlator3D to produce these very, very nice 3D models. You should use it.
Yeah. Yes, absolutely. And you You made me laugh so hard because I haven't found applications myself. Back when I started producing them, I mean the idea was to just showcase this for real estate purposes, but they were so bad that the owner, basically the owner of the company at the time told me, no, people are not going to buy that building when they see these terrible 3D models. They're going to run away. That building is melting. So it was terrible. Again, now I wish I could show him and be like, well, look at my 3D models now. They don't look like they're melting. So
and understand.
I haven't.
I understand the reality is the more time you spend editing to clean these things up, the better they're going to look, and the more time you spend collecting to capture for just this purpose, the better they're going to look. But it takes a lot of work, so be aware of that.
Yep, a lot of work, and check your hardware, guys. That's something that I always recommend. While software is extremely optimized, you can't imagine how, guys, R&D takes the time to make sure this software is optimized to use little resources as it can. By itself, 3D modeling in general, it uses resources in any PC. So be mindful of that.
All right, so let's finish up. David, thank you for that demo. That was fantastic. I think people can certainly see the difference in what a 3D model looked like back, when it was DSM based in 2.5D and what it looks like now. And as you said, our R&D group and our developers spent a lot of time getting this just how they want it, to be fast, to be efficient, and to present good results, really good results, and be part of the backbone of what's coming in the future. Because as you know, we have updates all the time. And we mentioned earlier that there were a few other things in here. And one of them was the ability now to use polygons to clean up flight lines, which, I mean, we're all excited about that. That's great. The other was that the DSM True Ortho. When your project is to build true orthos, there's that button you can select that says build the DSM, and that DSM will be built slightly different than a typical DSM to clean out some of the garbage, some of the spikes, and all those things that are, can cause stress in your true ortho. With that, I think we've covered everything. I'm sure you're going to get a lot more questions on the support side as people start using this.
Just a quick reminder there in my commercial, use the support portal, check out our community forum, and check out those great reference documents that Eric's putting out. So, yeah.
Well, I'd like to thank my guest, David. Thank you. I'd also like to thank those that attended the webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as all of our previous webinars, are available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks for joining us. Until next time.